All right. So I'm going to do greatest common factor. And I'm going to pick two numbers to do this with. My first number is 144. The next one is 48. And I want to find the greatest common factor. Greatest common factor between both of these. Okay. Now, when they're even, just start cutting by 2. So if I say, 144, I don't know what the answer is. I just do long division. 2, 144. So 2 goes to 144. Well, 2 goes into 1 0 times. 2 goes into 14 7 times. 7 times 2 is 14. Bring it down. Subtract them. It's 0. Bring down the 4. It's 2. So I can say, okay, this is 2 times 72. Okay. And then I might ask myself, well, I don't know what half of, because this is still even. I can still cut it with 2. So I got to go again. 2 goes into 72. Okay. I can sit there and say, well, that'd be 3 times 2 is 6. Bring down the 1. I'm going to bring down the 2. It's 12. It's 36. So I'm going to do this again. 2 times 2 times 36. At this point, I can pretty much start cutting on the half mentally. If I do the next one, it'd be 2 times 2 times 2. And what's half of 36? That'd be 18. I can cut this again. So it'd be 2 times 2 times 2 times 2 times 9. Okay. And then obviously 9 can be factored into 3 times 3. So my last one would be 2 times 2 times 2 times 2 times 3 times 3. Okay. Now, you might not like to write all these 2's and stuff out. There's an easier way to do it, and I'm going to show you how to do that. So what I'm going to do is I'm going to take this thing and I'm going to erase the whole board and start all over. 144 is equal to, and I already know the numbers, 2 times 72. Okay. And if I think I'm going to cut it in half again, I just do 2 squared, right? Because it's 2 times 2 times, what's the next number? 36, right? If I do the next number, it'd be 2 cubed times 18, because it's another 2 being added. Just keep adding a number every time I to the exponent every time I use a 2. And if I do this again, it'd be 2 to the 4 times 9. And if I break it down, the 9 again, it'd be 3 times 3. I would go 2, 4 times 3 to the square. Okay. These are the prime factors of 144. Let's do 48. I'm using the same concept. Okay. Half 48 would be 2 times 24. 24 cut in half would be 12. So I'm going to put a 2 over here, right? So it'd be 2 squared times 12. If I do this again, right, it would be what? A 6. So I can go 2 cubed times 6. If I break it in half again, it'd be equal to 2 to the 4 times 3. Now look at these two numbers. These are my ends I have on this thing. That's gone to completion, both of them. What do they have in common? Well, between both of these things, they have 2 to the 4. Okay, so I'm going to cross that out because I'm using it. And it says 3. It says 3 to the square. So I could take these two. It can't be squared by 2, 4 times 10. Times 3. Now, this actually equals 48, right? Because we already said this is all equal, right? So let's check our work. 48 goes into 144 how many times? Well, there was a 3 left over because this is 3 squared. It should be 3 times. So let's find out. I'm making this a long division thing. Does 48 go into 1? No. Does 48 go into 14? No. Let's see if the 3 works. This will be fun. 3 times 8 is 24. 4, 2. 3 times 4 is what? 12 plus 2 is 14. Voila. All right. So 48 is a factor of 144. Okay. Let's try another one because that one was kind of long, and I'll pick something that's I don't know. How would you say just kind of a whole lot easier than this? Let's try this. Let's try uh 65. Okay. I'm gonna try number 65 and 225 just for fun. Okay. So we have 65 on top and 225 right here. Okay. Now 65, since they both end in 5, we know 5 is one of them. There's no even, so I wouldn't cut by 2. And so I'm going to just use right off the bat. If it's a 0 or 5, I'm going to cut by 5. So go 5 times what number? Well, let's try this out. 5, do long division if you get stuck. 1 times 5 is 5. Bring down the 1, bring down the 5. So now we got 15, 13. Oh, well, this actually is going to be an easy problem because that's a prime number. That's a prime number. We're done with him. 225 may be another story. Okay. So the first thing we do is take out the 5. Okay. So I would do it this way. 5, 2, 2, 5. 5 goes into 2, 0 times, can't use it. 5 goes into 20, 4 times. 4 times 5 is 20. Bring down the 2, bring down the 5. It's 45. So it's 5 times 45. We're stuck here. We're at the end, but let's keep going with this guy, right? We have a 5 again. So we're going to, divide it out by 5. So it'd be 5 times 5 times, everyone should know that this would be 9. All right. Now, you could also have written this 5 squared times 9. That's the same as this, right? And then your next move would be breaking this down. So it would be 5 times 5. And the prime numbers of 9 would be what? 3 times 3. Once again, it can be written like this, 5 squared times 3 squared. So if we look at these two guys, this one and this one, what do they both have in common? Only 1 5. So 5 would be the greatest common factor of these two numbers. I hope this makes a little more sense. We're going to try one more and call it a day. Okay. So I'm going to hit that clear, right? And let's grab something a little interesting. Well, let's try 50 and 75. 50, 75. Actually, let me give myself a little more space here. 75, 75. And let's use 125. All right. Let's see what we get here. They all end in 5s or 0s, so we could use 5 automatically. So this would be 5 times 10. Okay. You break it down again. What would we do? Well, this could be 2 times 5, right? So I can have 5 squared times 2, right? So that'd be 5 times 5 is 25 times 2 would be 50. We're done here. We can't go anywhere else with him. Break this down by 5. If you're not good with the math, do the long division. It doesn't hurt. So 5 goes into 7 1 times. 1 times 5 is 5. Bring down the 2. Bring down the 5. 25. We should know that's 15. So this would be 5 times 15. Okay. Now we could break this down again by 5, right? So that'd be 5 times 3. So this would be 5 squared times 3. Okay. Now we're stuck, both prime numbers. Okay. Erase this so we don't see this. Okay. And now we're going to do 125. Oh, let go. Right. This would be 5. Of course, we're going into 125 first. 1, 2, 5. Can't go into 1. I'm just going to put a 0. 5 goes into 12 2 times. 2 times 5 is what? 10. Almost put the wrong letter. That'd be 10, right? And you subtract the 2, you get a 2. Let's bring down our 5. 5 goes into 25 5 times. Oh, nice. 5 times 25. Now, if we think about this, 5 times 5 is 25. So there's 2 5s here, right? So essentially, it would be looking like this. 5 times 5 times 5. for all practical reasons, we're just going to write 5 cubed. They're equivalent. So we're going to ask, what all do they have in common, right? So I am going to change this a little bit so I can see what I'm looking at. I'm going to put this here because I don't want too many numbers on the field when I'm doing this. Boom. This would be 5 cubed. They all have 5 squared in common. So I could cross this out, and obviously I can't use all of this, right? So I could think of this as 5 squared times 5. I took out one of the 5s, right? Okay. So in that sense, it'd be 5 squared being the greatest common factor, which is 25. That's kind of how you would do these things. We're doing this because eventually we're going to reduce fractions and stuff using this methodology. So hopefully that makes sense, right?